Hi guys, for your copper and sulfur lab, you need to make something called a histogram. Histograms are graphs that show the trend in your data, and at the same time, they show you how precise your data is, how close together the numbers are. In any experiment, there's going to be some sources of error and some variation in numbers just based on the ability of humans to measure. We can't measure anything perfectly. In the experiment that you're doing, you're using a triple beam balance, and our triple beam balances come from the manufacturer with a range of precision of plus or minus 0.02 grams. And what that means is that if the real mass of something is 23 grams exactly, then the manufacturer is saying, look, we'll guarantee you that the highest mass that you'll get for that would be 23.02, and the lowest you would get would be 22.98. In other words, they're telling you there's a range of 0.04 grams around which there's some uncertainty. You're not 100% sure. Now, the balances, we've had them for a long time. They haven't been serviced in a couple of years. So I think the range of precision has gotten higher. So I now feel that they are plus or minus 0.04 grams. So that, if you mass something and it is exactly 23 grams, you might get 23.04, you might get something as low as 22.96 grams. But what I've done is I've created a histogram for you that takes into account the range of precision of our instrument. Our instrument is the triple beam balance. So if you look down here on your histogram sheet, it might be easier for you to look at the actual sheet than the one on here because this is really small. Down at the bottom, you see ranges of numbers, right? Starting all the way on the left, it goes minus 0.68 to minus 0.84. And right in the middle of that would be 0.76 right here, negative 0.76. Now these are small numbers, right? And the negative indicates a loss of mass. So any loss of mass that falls between negative 0.68 grams and negative 0.84 grams is going to go into that bin. And by bin, I mean this darkened column here that's 3 wide and this tall. That's a bin. So into that bin would go any numbers that fit between negative 0.68 and negative 0.84. Now, we don't have any numbers like that in my sample over here. These are sample numbers. So I don't put anything in that column. The next column goes from negative 0.52 to negative 0.68, and I still don't have any numbers that fall into that category. I just realized this should be a point in front of that O2 there. And I can keep going line by line and look for numbers that fit into each bin and plug them in. Let's find where each of these numbers goes. Since I only have a few numbers, it's probably easier to do it that way. Where would 0.08 go? Well, this is a little bit tricky because where 0.08 goes is actually in this bin here, right? 0.08 and negative 0.08 are a range over which 0 is the middle. That's a little bit weird for some students, right? The exact mean or middle between negative 0.08 and positive 0.08 averages out to be 0. So actually 0.08 could go in there. But look, it could also go in the bin next door, which starts with 0.08. This is the interesting thing about histograms. Each bin contains a number that is also found in the bin next to it. And as a result, you have to make a decision if you have a number that falls on the border between two bins. You have to decide, where are we going to put 0.08? Now, it doesn't actually matter where you put it as long as you always put numbers that are like that the same way. So what I do is, for the whole class, I say, we're going to go right. And I ask that any histogram you make, you draw an arrow in the upper right-hand corner indicating that you're going to go right. Anytime a number falls on a boundary, you're going to put it to the right. It's important to note that because it does introduce a slight error into your graph. So how do you put 0.08 into a bin? Well, since we're going to go to the right, it's going to go here. And what I do is I make a box for it right there. Just one box up. 0.02 goes where? 0.02 fits actually in the bin to the left of that because it falls between negative 0.08 and positive 0.08. So there's going to be a box there. Interestingly enough, so does negative 0.02. Negative 0.02 is in the same place. What do you do now? You put the box right on top of the other box. 0.07 is also going to fit in that bin, interestingly enough, because it goes up to 0.08, right? There you go. And then what I like to do is just, circle them so I keep track, because if you have a really long list of numbers, after a while you can lose track of where you are. So we've done these 4. Negative 0.04 also goes in that middle bin there. Look at that. And then 0.80 is an interesting number. It falls right here. It's way over here to the right. But what if I had a number that was bigger than 0.84? 0.84 is the end of this bin. If I had a number like that, what I would do is right underneath where I wrote my arrow, I would create what I call an outlier box, and I would label it outliers. And any numbers that don't fit on my graph, either because they're too far to the left or too far to the right, I would write in there. So let's say I had like 1.9, or 1.90, I should say, grams. I would stick it in there in my outlier box so people know there are things that are not on my graph. Now, this is not a very detailed graph because there's not that much data. Only 6 data points, not that much data. I'm going to try and give you the data from all 4 of my classes if I can. If not, I'll just give you data from 2 classes to make your histogram. But what you're going to see is that you're going to start to see a pattern, or at least we hope you start to see a pattern. What we're getting is this is our tallest bin so far. And the mean or middle of that bin is 0. So in other words, if this were the data that I got from the experiment, I would say, oh, the mass didn't change, right? It stayed around 0. Even though nobody got the number 0 as their answer, you can tell that given the range of precision of our instrument, the fact that the triple beam balance doesn't measure perfectly, and we're not perfect measurers, given that, these numbers that are in here, except for that one that's not circled, all these numbers over here are really close enough to 0 to be considered 0. In other words, your triple beam balance can't tell the difference between 0 and 0.08 or negative 0.08. Your balance is just not that accurate. And that's why I'm grouping all these numbers together. Now, when you do the experiment for real, you may find that the data falls in a totally different bin. Maybe you'll gain a little bit of mass. Maybe you'll lose a little bit of mass. It depends on what the outcome of the experiment is. But the whole point of a histogram is to try and find the mode when your mode is not an exact number. It's a range of numbers. And you can see that a whole range of numbers, all the numbers that fall between negative 0.08 and positive 0.08 are the mode of this particular group of data. Hopefully that explains for you how to make your histogram. When you do yours, don't forget a couple of important details. Number 1, you need an outlier box if there are any outliers. Number 2, don't forget to put your go to the right arrow, because we all go to the right with any numbers that fall exactly on a border. And make sure that as you're doing this, you try and keep it nice and neat. Some students find that it helps them, and I don't mind if you do this. Some students like to write the actual numbers into the boxes. So, into that, for each of those, you would write 0.08, 0.02, negative 0.02, etc. And that's okay, you can do that. That might help you keep track of your numbers a little better, and it certainly doesn't hurt anything for you to do that. I recommend doing this in pencil, and then if you don't like the way it looks when you're done in pencil, you can always outline it in pen later. But it's very common to make mistakes when you have a long list of data, so I recommend that you start with pencil. Hopefully this helps you make your histogram, and I'll see you in class.